Hello everyone, my name is Ludwig Sidemark, and together with my co-workers Tianyu Chang, Lina Lababidi, Janan Lee, and Tove Grossman, I'm happy to present Desk2Desk, optimization-based mixed reality workspace integration for remote side-by-side collaboration. And before I start, I'd like to especially highlight Tianyu and Lin, who with this project did their first ever MR project with me as undergraduate assistants, and without their efforts I would not be standing here now. All right, so knowledge work is mainly conducted in front of physical screens, enabling long hours of work with minimal fatigue. And collaborative tasks, such as pair programming, typically occur side by side in a seated position and enables tight-knit collaborations as users have a shared frame of reference to which they can refer to with speech and gestures. And this work aims to support this type of collaboration in a remote setting through mixed reality. So by bringing the collaborator to your physical workspace and similarly bringing you to their physical workspace. Remote mixed reality collaboration, however, is particularly challenging because users operate in separate physical environments. So a successful collaborative system must unify these dissimilar spaces to prevent confusion. And in seated workspaces, the number and layout of screens can vary significantly. And this discrepancy poses challenges for remote collaboration as the cues present in local side-by-side collaboration may become counterproductive due to inconsistent screen layouts. And integrating virtual elements into physical environments is challenging due to varying physical limitations. And this has led to several layout optimization efforts to find optimal positions for virtual elements, as we saw just before. And for collaboration, partially blended realities has been proposed where only essential physical objects like tables and whiteboards are aligned. And we draw inspiration from this by focusing solely on optimal screen placements to simplify workspace integration. So what we end up with is an optimization-based collaborative system where two collaborators' MR workspaces consisting of both virtual and physical screens are integrated, and the virtual avatars of the two collaborators are also integrated. And the shared content of each user is streamed to the collaborator, and screens are dynamically spawned and placed as needed. So there are many moving parts to this, so to explain Desk2Desk, I will go through an example of two users connecting and collaborating step by step. So each user starts with their local workspace. So as we can see on the top, user A has 3 physical screens, while user B only has 1 physical screen to integrate. And to begin workspace integration, users label their screens either as private, which means that it's hidden from the collaborator and excluded from integration, as shared, that you want to share it to the collaborator, or as available, which means that it's unused by the local user and can display a shared screen. So going back to our example, user A assigns 2 screens to share, and 1 is assigned as available, while user B assigns their screen to share. So in the next step, the workspaces are integrated and screens are spawned and placed as needed, and the collaborator is also spawned as a designated position. So we start this process by transforming the hybrid workspace into a virtual representation. So usable space is subdivided into a 3D grid of smaller voxels that represent possible screen placements. And before optimization, we remove unusable voxels that intersect physical objects, occlude screens, or are too close to the user. And each screen and remaining voxel are assigned a semantic value based on its usefulness, which we use in the optimization process. So after connecting, the optimizer creates an optimal combined workspace for both users by mapping screens to potential position based on each user's unique environment. And the goal here is to make the 2 workspaces as similar as possible. And note, however, that we do not move content of screens between screens, we only move the positions. However, before optimization, we perform a pre-solving that checks for physical screens labeled as available that cannot be moved. And these are paired with share screens of the other user based on semantic value. So in this case, for the pre-solving, if all screens are paired successfully, then no further optimization is needed. So our optimization has 4 objectives. So first, it tries to maximize workspace agreement to minimize inconsistencies between users by aligning workspace shapes. Second, we try to preserve the initial layout to keep users' original screen arrangement stable before and after integration. We try to optimize screen placement by placing high importance screens closer to the user's central view. And we try to maintain consistent depth to reduce visual discomfort and create a uniform concave layout. So together with constraints to prevent screen occlusion and overlap, Desk2Desk spawns and places virtual screens in the most optimal positions found. So going back to this example where user A assigns 2 screens to share, while one is assigned as available, and then on the right we have user B assigned their 1 screen to share. So after integration for user B, 2 screens are spawned and placed in the optimal position so that user B can see user A's shared content. And meanwhile, user B's screen is overlaid on the available screen of user A via the pre-solving process. And the avatars are spawned, and the users can now see each other content, each other, and collaborate. So finally, during collaboration, we perform gesture retargeting. And this is because it's unlikely that the workspaces are identical due to physical restrictions. So going back to our example, we can see that the pointing gesture of user B is retargeted to point at the same screen position in user A's workspace. And we can also see that the gaze direction of user A is retargeted so that they look at user B. And if you want to know more about the retargeting algorithm, please refer to the paper or ask me about it during the coffee break. But just to show this in practice, we see on the right side user B is pointing towards the screen upwards, which on user A's view to the left is redirected to the central screen. And vice versa, user A is pointing at their right screen, which is redirected to the central screen. So we conducted a user study to evaluate Desk2Desk using a planning and negotiation task. So participant pairs had to select a hotel based on conflicting criteria, requiring them to negotiate to find the optimal hotel to book. So 2 participants worked in separate rooms with different workspace setups, using a custom hotel listing website, a virtual whiteboard, and a Google Doc for notes. And we compared Desk2Desk with a Zoom-inspired baseline, testing its effectiveness across different workspace configurations. So I won't have time to go through all the results, so I'll just go through some highlights. So we found that participants thought that seeing each other's screens was very useful for collaboration. Participants thought that the screen placements from the layout optimization made sense. By quantifying participant references during collaboration, we found that Desk2Desk effectively supports physical pointing gestures. We also found that the physical gestures were generally made to refer to specific screens, while the cursor or verbal references was often used to refer to specific screen elements. And then also we found that participants also thought that the partner avatar increased immersion and a sense of collaboration. We also find some interesting observation during the study. So one was that hand tracking faced challenges in these settings, as participants often moved outside the tracking area, for example, behind their head because they wanted to play with their hair, or under their chin to think, as in the pictures. Basically, people got very comfortable during the study, and some were like leaning on the table and all of that, which led to some unexpected avatar movements. However, this mainly went unnoticed since focus was forward on the displays, and people really only occasionally looked directly towards their avatar. Another thing is that user relative references cause confusion. So for example, if someone said, look at the left screen, this might not be the other person's left screen. And usually they would recover from this, but sometimes they were very persistent in using these sort of references, which caused some confusion. And this is because of our decision to prioritize shape alignment of workspaces rather than screen pairings. And this could be further explored in the future. We also found that participants that had fewer screens before integrations were much more appreciative of the system, as they did not have to fight for screen real estate with Desk2Desk, as the screens are dynamically added. And then finally, participants also mentioned that they wanted more integration by, for example, being able to control each other's screens, and suggested enhancing the avatars with eye tracking and other things for extra realism. So to conclude, we introduced Desk2Desk, a system using optimization techniques to enable effective side-by-side collaboration in mixed reality workspaces. And our approach adapts layout optimization to collaborative scenarios, helping users share information and work together. And our study shows that adaptive workspaces are especially helpful in setups with limited physical screens, enhancing collaboration and immersion. And this work opens up new possibilities for collaborative systems that integrate virtual and physical workspaces. So that is all I have for this presentation. A final note I'd like to say is I'm currently on the job market for industry research and tenure track positions. So if you are excited to see more of this type of work in your research lab or faculty, then come talk to me. And I'm happy to take any questions.
Steve Fryer at Columbia University, great stuff. I have one question about the physical screens. So
Yep.
you're wearing headsets
Yep.
with video pass-through,
Yep.
which is way inferior compared to
Yes.
your direct view.
Yes.
So how are you dealing with the fact you're forcing people, unfortunately, to look at these physical screens being seen through inferior cameras?
Yeah, so what we did was that we actually overlaid virtual screens on the physical screens. So we used the MetaQuest Pro, which doesn't
Right.
have a great pass-through. So that was our solution to that, just for the study. And we also, because of this, had to lower the resolution for the screen. So it was
Right.
something like 1,000 pixels wide and so on. And this was something that, of course, this is something that in the future, when pass-through becomes better
Sure.
and so on, this is hopefully improved. But that was sort of how we dealt with it. But that is definitely like a limitation of the current system.
Okay, thank you.
Thank you.
Hi, lovely, lovely work. Yifei Chang, Carnegie Mellon University. I'm curious about how well this would generalize across different diverse workspaces and devices, if you could speak a bit to that.
Yes, so in our study, we only tested a few combinations, so where it ranged from one person having one screen, another two screens, and so on. So we only tested a very few ones, and these are the most common ones that we found in previous surveys and so on. But obviously, there's essentially like a almost endless amount of combinations, and with our playing around, we found that it worked quite well, but this was just our own testing. But I do think that we do a lot of assumptions as well, that the physical screens are not movable, that they are all in the same size, and so on. So I think there's a lot more work to do with this stuff.
Lovely, thank you so much.
Thank you.
Hi, I'm Hiroshi Ishii from MIT, and it's very impressive work to
Thank you.
really tackle how to make a seamless extension between here and there. One question, you took a side-by-side metaphor.
Yeah.
Have you explored through the screen facing each other like a Collaborat 1992?
I think that's a very interesting idea. I think the main reason we didn't do that is because we assumed that the desk would be towards the wall, so then it would be almost like the avatar is inside the wall or something like that. But obviously not all desks are like that, right? You have meetings in front of each other, and I think the approach we had was here that I think a lot of collaborative works in VR and AR and so on is sort of in this sort of standing position where you're standing and collaborating and so on. And we wanted to explore, okay, how do you do when you're sitting down and working together? Because I do think that we are lazy creatures and we like to sit down, which I think is also more nicer if you're gonna do more longer collaborations and so on. But so in this case, we did the side by side, but I definitely agree that doing the forward is nice because then the avatar or the other user becomes more in your view all the time and so on. This was something we noticed. Some were very during the study, some were very attentive to the collaborator, and some, they focus solely on the screen, basically.
Jim Horan wrote a very seminal paper in CHI 1992 called Beyond Being There.
Yes.
So to solve fundamental problems,
Yes.
maybe sticking too much of current physical arrangement side
Yes.
by side might be the issue. So I encourage you to also explore different metaphor beyond side by side,
Yes.
not get strained by reality or simulation. That's my advice.
Yes, thank you.